It turns out that cancer research is really a subdiscipline of evolution. It's surprising, but it's true that evolution is the theory of cancer. And if you look down into a tumor, what you see is a microcosm of evolution. The cells are mutating and competing, and it's the survival of the fittest down there. And those mutants that are better at surviving and reproducing will spread through the tumors and eventually become malignant and maybe kill us in the end. There's a lot of ways in which evolution impacts cancer because it is the theory of cancer. It tells us about how cancer develops and gives us ideas of how we could prevent it, but also tells us how it evades our therapies and how we might prevent that and do better in therapy. So for example, Bob Gatenby had the inspiration from agriculture, where the farmers have learned how to suppress resistance in pests. They have the same problem. You spray a field with pesticide and you kill most of the pests, but you select for mutants that are resistant. Well, when we give chemotherapy, we're spraying the field of the tumor with a chemotherapy pesticide, and we kill most of the cells in the tumor, but we select for resistant ones. So what the farmers learned was if you just go for the eradication, for the cure, it never works. You end up losing control and you get a whole field full of resistant pests. But instead what they do is they keep some sensitive pests around. They don't spray part of their fields, and that helps control the population because the sensitive pests can outcompete the resistant pests. Or in other words, the sensitive cells, the cells that would die from your chemotherapy, can usually outcompete the resistant cells because there's some cost to resistance. So you develop what's called adaptive therapy, where you adapt the dose with the goal of keeping the tumor at a stable size. So this is radical. You don't try to cure the tumor, you keep it under control, but you can keep it under control indefinitely. And this has worked well in mice and models of ovarian cancer and also breast cancer, and now they've got a clinical trial in prostate cancer in humans that seems promising with the first 11 subjects. One of the hottest fields in cancer research is what they call the microenvironment. What are all the other cells doing in there? The immune cells, the fibroblasts, the fat cells. And it turns out this is really ecology. It's the interaction of different organisms and also the nutrients and other structures in their environment. And we have a long tradition of how to study ecology that's just now starting to be applied to cancer.